Hello everyone, my name is Ibrahim, my surname Mama Janet, my student number is 2020-2549. Now I am going to give presentation for the final exam of the linear algebra. Okay, let's start. Okay, at the beginning of my presentation, I'm going to explain whole topics of the linear algebra, and then I'm going to explain the formulas of the topics. Okay, at the beginning of the starting learning something, we should know what is that. What should we learn? Okay, so I'm going to start now from the vectors. Okay, a vector is a quantity with a both size and direction. Grammatically, a vector can be responded by the directed line, a segment whose direction points in the direction of the vector and whose length is proportional to the magnitude of the vector. Okay, how to write a vector? A vector can be written down in several ways. One method is used to the bold characters. You can also use an underline or the arrow down of the top of the letter. If the symbol for the vector is written without this, it is taken for the beam magnitude of the vector. To find the component of the vector is a given direction, draw a line parallel to the needed direction, processing through the tail end of the vector, then the drop of the perpendicular line from the nose of the vector onto this line. Component of the vector is a given direction is, then the length of the line from the tail of the vector to the dropped perpendicular line. Okay, this is the definition of the vector, and I try it a bit explain about vector. What is that? Okay, let's move to matrix. What's a matrix? Ever wondered what the elements in a matrix mean? Why is it responded in a particular form? Why do we study matrix? Does it have any real life application? I would say yes. Matrix are the most important and are the basic part of the math, which are used in higher studies and real-life problems. Matrices are one of the most powerful tools in the mathematical. The evolution of the component of the matrices is a result of the attempt to obtain concept and the simple method of the solving the system of the linear equation. Okay, at the end of the matrix, I tried to explain about the matrix. I hope I could give a bit information about matrices. Later, we will see the formulas of these topics. Okay, let's go to dominance. In the mathematics, in the math, the dominance is a scalar's value that is found function of the integers of the square matrix. It allows characterizing some components of the matrix and the linear map responded by the matrix. In the particular, the dominant is a non-zero if and only if the matrix is immutable and the linear map. Okay, let's move to the inner product. In the math, inner product spaces or rarely Hausdorff pre-Hilbert space is a real vector space or complex vector space with operation called inner product. The inner product of the two vectors in the space in the scale often denoted with the angle brackets such as in the inner products allow forms. Definition of the intuit definition of the intuitivity geometric notion such as the lengths, angles, and the organ organically. There was the inner product of the vector. Okay, let's move to the next topic. Okay, and next topic is outer products. In a linear algebra, the outer products of the two coordinate vectors in a matrix. If the two vectors have the dimension n and m, then their outer product is n multiply m matrix. More generally, given two tensors, multiplication arrays of numbers, their outer product is a tensor. The outer product of the tensor is also referred to their tensor product, can be used to define the tensor algebra. Okay, let's move to the complex number. The complex number is helpful in defining the square root of the negative numbers. The concept of the complex numbers was first referred in the 1st century by the Greek mathematical hero Alexandria, when he was trying to find the square root of the negative numbers, but he merely changed the negative into the positive and simply took the numerical root value. Further, the real identity of the complex number was defined in the 16th century by Italian mathematical Gerolamo Carnao. Is a process of finding the negative roots of the cubic and the quadratic Boolean expressions. Complex numbers have application in many scientific research, single processing, elimination, fluid dynamics, and vibration analysis. Here we can understand the definitions, the diagrams, visual complex numbers with the formulas during our presentation. Okay, here I explained a bit about some topics, and let's move to the learning the formulas of these topics. And during our presentation, we can learn the formulas of these topics which I explained it.
Okay, let's move to the next. So here we are going to make the work with NumPy library of the Python. So in order to kind of make operations on matrices, we need NumPy library from Python. It's pretty simple and easy to use. So here we have Jupyter Notebook. So I've written all the codes here, readable codes. So in order to import the NumPy, we need the following code, and I imported it as an NP in order to not write all the time NumPy. Just simply NP means NumPy. So whenever you see NP, it means NumPy. So, and there are a number of really useful functions for matrices to make some operations on matrices. So for example, dot array, like not array, so v dot, here we have dot, here we have inner product and outer product. So they are pretty simple. You just use function np dot, the function name, and in the brackets useful kind of necessary items. So in order to find dot product of two matrices, we need the following function. If you say, and if you we print in the console, so print np.ab. So these two functions, it will definitely find the dot dot product of these two matrices. For example, this line will print 12. This one line will print like multiplying 2j to 2j, 3j to 3j, and they plus. So it is equal to like 4j, 6j. So let's see in the console. So let's run it. As you see, guys, here, so here we have 12. The dot product of 3 and 4 is equal to 12. And the dot product of these two is equal to minus 13 plus 0j. And here we have dot product of these two 2 by 2 matrix. So if we multiply these two, 2 1 2 2 matrix will be the result. So let's move to the next. In order to find dot product of the two matrices, we can use a v dot. So if you run this code, you see the answer is this. So the out is with red color is because we didn't write print the command to print it in the console. If you see here, now here is the result. So the v dot product of these two complex matrix 1 by 2 is equal to 70 minus 8j. And here we have another example of v dot with integers. If we run this, you see the answer is 30. So it's really useful in data visualization in data science branch, just usually useful in linear algebra. So in order to find inner product of two arrays, we can use the following code. np dot inner, in the brackets we need to provide the matrices. Let's run this code and see the result. If we run, say you say the 2 is answer. So this was the inner product, and outer product is the same, but if you wish, you can provide the data type in order to print the type. So let's run this. As you see, so here we have the outer product of two vectors. The first vector was a, b, c, and the next vector was 1 2 3. The outer product of these two matrices is the following answer. So let's move next. Matmul. However, so this is also used for product of two arrays. However, it's different from dot. So if we go to documentation of numpy org, so numpy Python. So here we can see the difference between dot and let's go to documentation. Here we have documentation. So let's search for matmul function. Okay, here we go, numpy matmul. So here it is. So here you see a matmul differs from dot in two important ways. First way is multiplication by scalars is not allowed. We need to use star instead. Stacks of matrices are broadcast together as if the matrices were elements, respecting this signature. So here we need to take note of this. So as you see, the difference between dot and matmul, so the difference is here. We have here 6 elements, here 4 elements. So, but as both the display the product of two matrices. Let's see run this code and see the result. So here we go. Here is the answer of the product. So these were the formula for matrices. Now let me move to the what is a vector. So vector, so exactly, so let me describe it. Vector is a line which has direction and it has length too. So but it is really different from lines, like from which has endpoints in both sides. These vectors have only one endpoint in the beginning from the origin endpoint and the direction. Next One would be not endpoint, but that shows the direction where our vector is going. So for example, in this chart, you can see the vector. Yeah, whenever you see a line which comes from the origin of the coordinate and goes to some direction, it is vector. Vector is described with the coordinates from first of all with 1 and then 2. This is vector 1, 2. And vectors has special characteristics that they have arrow above them. So, and here we can see, so we need to recall that a vector has a direction where it's points and it has a length too. Later we will learn how to find the length, the magnitude of the vector. So here, as you see, the two main characteristics of vectors are that the vectors have directions, you know, they may be directed in many different sides. So, and we have lengths of the vector. Vector doesn't go on. Do not believe that it has like arrow and it may continue. No, it doesn't continue. It has some certain lengths. So let's move the two-dimensional vectors. What are two-dimensional vectors? Two-dimensional vectors are the vectors in two-dimensional coordinate. So as you see, okay, so maybe, okay, let's continue. Two-dimensional vectors are vectors in two-dimensional space, each two-dimensional line. So for example, so we have x and y axis. So if we demonstrate the vector in this axis, it's two-dimensional. Yeah. In 2D plane. So, but vectors can also live in a 3D space. Yeah, they will have 3 dimensions, x, y, and z. That's the difference in between vector 2-dimensional and 3-dimensional. So here are the vector examples. So definition of the vector. So vector is within the scope of the linear algebra. A vector is defined under the operation of summation and the multiplication by a scalar. You see here, so vectors can be added. So addition of uh, matrices. So vectors be like this. So for example, here we have V, here we have W, and the addition would look like this purple line, V plus W vectors. So, and we can multiply by an integer, by a scalar value. If we multiply, it means two two vectors going the same direction and they lie on the same line. So it's demonstrated as 2V. So here is the notion of vectors. So, okay. So, okay. Here you can see some codes in terms of in NumPy. So let's keep continue. Yes, vectors addition. In order to see the result of the vector addition, it's pretty simple. If you keep them in a variable and you add, you can simply get the result. So scalar vector multiplication. Scalar vector multiplication is that you multiply an integer number with a vector. So in this pretty simple, you need to multiply the integer into every single item in the vector in the matrix. So that's all, I think. Thanks for the attention. That's the end of my presentation.